Good morning, students. This is Harsnath Shukla, and today we are going to discuss lecture number 2 for class 10th. So, as you know, we had already discussed Euclid division lemma to prove root 2 is an irrational number, and etc. So, today we are going to discuss some more questions based on irrationality of the irrational number. So, let us see the question. Prove that 5 plus 2 root 3 is an irrational number. Prove that 5 plus 2 root 3 is an irrational number. For this, first we said take solution or proof. If possible, let 5 plus 2 root 3 is a rational number. Is a rational number. Okay? So what we have? 5 plus 2 root 3 can be written as in the form of p by q or simply a. Okay, so this is nothing but a rational number. Okay, so 2 root 3 can be written as p by q minus 5. This is also a rational number because if you subtract a rational number from rational number, again a rational number. So root 3 can be written as p by q minus 5 whole divided by 2. So this is also a rational. Why? Because if you divide a rational number by a rational number, you get again a rational number. So this is the contradiction. This root 3 is an irrational number and this is a rational number. So an irrational number does not equal to a rational number. That's why this is contradiction. So our supposition that 5 plus 2 root 3 is a rational number is wrong. So what is true? 5 plus 2 root 3 is an irrational number. Okay, so note it down and then after we shall discuss some more questions. Okay, okay, maybe you completed this one. Now we are going to discuss terminating and non-terminating. Terminating and non-terminating decimal recurring, non-recurring. So if a decimal expansion can be represented in the form of denominator of that particular fraction or rational number can be represented in the form of 2 power n into 5 power n, then this particular number is terminate. That means this is terminating distance, otherwise non-terminating. So in that also terminating, non-terminating, so terminating and non-recurring, okay, terminating, recurring. So there are some theorems which is already written on the NCERT book, so you can note it down and you understand here which type of decimal expansions can be terminated and which type of decimal expansion cannot be terminated. So let us discuss a question. 7 upon 1600. If we talk about 7 upon 1600, then you can write 7 upon 1600. This is 2 into 2 into 2 into 2 16 into 2 So you can write here 2 into 2 into 2 into 2 into 2 to 5 into 5. Okay? So this denominator can be expressed in the form of 2 the power 6 into 5 power 2. So this is of the form 2 power n and 5 power n. So this decimal expansion can be, this decimal expansion is terminating. This is terminating decimal. Okay? Terminating decimal. So note it down. Okay. Now next one. Seven by 75. Suppose we can discuss 7 by 75. So denominator of this particular expansion 3 into 5 into 5. So 7 upon 3 into 5 power 2. Okay. So this decimal expansion is not terminating. Why? Because the denominator is not in the form 2 power m into 5 power n. That's why this particular decimal expansion does not terminate. This is not terminating. Hence, decimal expansion does not terminate. Okay? For decimal expansions to be terminating, we must have denominator as a prime factorization of 2 power n into 5 power n. Okay? So note it down. Okay. Now next you see suppose we have given 12 upon 120. Okay. So the denominator, right factorization of denominator 5 into 5 into 5. So this is 12 upon 5 power 3. Okay. So this is not in the form of 2 power n into 5 power n. But if you see 12 upon 2 power 0 into 5 power 3. Now this is in the form of 2 power n into 5 power n. Denominator is in the form of 2 power n into 5 power n. Hence, decimal expansion terminates. Hence, this decimal expansion terminates. Okay? So note it down. Okay, so next type of question in this particular chapter. The given expansion 43 upon 2 power 4 into 5 power 3 okay will terminate after how many places? This question, okay. So in this question we have to find after how many places this decimal expansion terminates. So this is a very easy. You just see either power of maximum power of 2 or maximum power of 4. Which one is the maximum? Here power of 2 is maximum, that is 4. So after 4 places this decimal expansion has been terminated. So how? You see here 43 upon 2 power 4 into 5 power 3. So we multiply numerator and denominator both by 5. So this is nothing but 43 into 5, 5 3 is 15, 5 4 is 20 and 21 divided by 2 power 4 into 5 power 4. So this is 215 upon 10 to power 4. This 10 to power 4 means this decimal expansion terminates after 4 places. Maybe you understand? Okay. So what you see here, maximum power of 2 or 5. If 2 power 1, 5 power 3, then it terminates after 3 places. Okay. Note it down. Okay, so in this manner we have to finish this chapter real number. So again I am just going to remind you what are the topics in this chapter and you just complete all their exercises so that we have to start next chapter in the next lecture. So again I just want to remind you what are the topics. So in this chapter first topic is Euclid division lemma. You know very well. First one is Euclid division lemma, and you know very well what it is. For each positive integer a, b, there exists q and r belongs to z such that a is equals to bq plus r, where 0 is less than or equal to b is less than 0 is less than or equal to r is less than b. This is Euclid division lemma. So after that Euclid division algorithm. So we use Euclid division algorithm to find the SCF of two numbers. So this particular lemma is known as algorithm. If you use as an algorithm, suppose r is equal to 0, then last divisor b is nothing but SCF of a and b. Suppose r does not equal to 0, then we continue this process. Okay. After that we understand here some theorems. Fundamental theorem of arithmetic. That means prime factorization. In this particular theorem, any composite number can be represented in the form of prime factorization of prime factors of that particular number. Okay, so order doesn't matter. That means if you have 6, then this can be written as 2 into 3 or 3 into 2. Okay, now next one is if p1 p2 p3 dot pn is a prime number, then a composite number, suppose a, is can be written as p1 into p2 into p3 and so on. Pn. Okay, this is the fundamental theorem of arithmetic. Similarly, if a number a divides p square, then must divide p, and afterwards we have to show some root 2 is an irrational number, root 3 is an irrational number, root 5 is an irrational number, root 7 is an irrational number, 3 plus 2 root 3 is an irrational number, and so on. Okay. And afterwards, we see the terminating and non-terminating decimals. So, what are the terminating decimal and non-terminating decimal? If the denominator of that particular expansion can be represented in the form of 2 power m into 5 power n, then this particular number is terminates. Okay? Otherwise, non-terminating decimal. And afterwards, last one, what you see here? You just see how many places, after how many places the decimal expansion can be terminated. So suppose we have given some more questions like supposed to be 3 upon 2 power 2 into 5 power 1. So how many places, after how many places this particular expansion terminates? So first we see the power of 2 power 2 and 5 power 1. So we just multiply 2, 5. So you just see 15 upon 2 power 2 into 5 power 2. That is 15 upon 10 to power 2. That is 0.15. So you see here, after 2 places of decimal, this particular expansion, this decimal expansion has been terminates. So what you see here? Power of 2 or 5. Maximum power of 2 or 5. Okay. So in this manner we have to complete this particular chapter and revision also. So please try to complete each and every exercise of NCERT. Okay. So thank you.